Our view of the stars is limited. What we see in the gigantic expanses of the universe is by no means the big picture, but merely a section that is determined by a number of natural factors. But what is hidden in the part of the universe that is invisible to us? Is there even a way to crack this mystery? Well, there is, and the data collected suggests that there is something gigantic out there that has already stretched out its hidden arm towards our world. And the Earth is the center of the universe. But before you think that we have mentally strayed back to the Middle Ages, let us briefly explain what is meant by this. It should be clear to everyone that the geocentric view of the world, which places the Earth at the center of the cosmos, is long outdated. Nevertheless, our blue home planet is still the center of the observable universe. Because, as already mentioned at the beginning, our view into the depths of space is blinkered. Against the background that the universe is isotropic, in other words, that it always presents itself to the observer in the same way regardless of the observer's direction of observation, there is a spherical space around our Earth that corresponds to our cosmic field of vision. The radius of the observable universe is in turn determined by how far light has been able to travel to us since the Big Bang. And since, according to the standard cosmological model, the universe was born around 13.8 billion years ago, you might think that the optical barrier is also 13.8 billion light-years away from us, but that's not true. At this point, we must not forget that the universe has always been expanding, and that distances already traveled have been subsequently extended as a result. In plain language, this means that the observation horizon is not 13.8, but 46.3 billion light-years. And the most remote objects whose light we can observe today were just 40 million light-years away from Earth at the time they emitted that light. As a result, studying these boundary structures is always like optically traveling back in time. Since the light that is currently emitted from there can no longer reach us, it's also impossible to learn anything about the current processes at this distance. Against this backdrop, the question of what lies beyond the observable universe seems doomed to failure from the outset. However, despite all observation horizons and natural barriers to vision, there are some experts who believe they have actually cracked this riddle. As a result, a few years ago, researchers became aware of a strange phenomenon that stands in stark contradiction to our current assumptions and which could lead us straight to the deepest secrets of the invisible cosmos. Is there a cosmic giant hiding out there? Basically, according to the common assumptions of cosmology, the proper motions of galaxy clusters relative to the background radiation should be randomly distributed in all directions. And once again, for a brief classification, the background radiation, or more precisely, the cosmic microwave background radiation, embodies a relic from the time shortly after the Big Bang, which still fills the entire universe today. Between 2001 and 2010, NASA's Wilkinson Microwave Anisotropy Probe, or WMAP for short, was again dedicated to the task of investigating irregularities in the cosmic background radiation. And when the NASA working group, led by Alexander Kashlinsky, was busy analyzing the WMAP data in 2008, they noticed a strange pattern that should not actually occur in this form. The scientists did not identify a movement of galaxy clusters distributed in all directions, but an astonishingly uniform flow. And that's not all. To all appearances, the speed of the galactic stream also increased with increasing distance. The bottom line is that such a phenomenon can only be caused by an extreme gravitational force. But what kind of structure could be responsible? Well, unfortunately, this question cannot be answered with absolute certainty. After all the galaxy clusters studied are moving towards a point that lies outside the observable universe, henceforth christened dark flow. The galactic caravan was to be scrutinized again in 2010, with the result that the number of galaxy clusters floating along in the dark flow doubled from 700 to 1400. Although there were some differences in the direction of movement in the four observed segments, all areas showed a clear correspondence. Since then, astronomers have gained one more piece of evidence in favor of a massive structure with an extreme gravitational pull outside of the observable universe, and a tantalizing mystery. For while, according to Alexander Kashlinsky, there is no question that matter in the observable universe cannot explain the measured galaxy flux, we do not know in the same breath what is really responsible for it. In this regard, the NASA astronomer from the Goddard Space Flight Center is quoted as follows: "We don't have enough information to see what it is or to narrow it down. We can only say with certainty that the world somewhere far away is very different from what we see locally. Whether it is a different universe or a different space-time structure, we don't know." The dark flow theory criticized. So could it be that our cosmic field of vision hides an extreme accumulation of energy and matter that hopelessly exceeds all known orders of magnitude? Or are we dealing here with the effects of bizarre space-time distortions resulting from the influence of a neighboring universe? Well, the critics of the dark flow theory answer these questions with a decisive neither, for the very simple reason that the leading researchers are said to have made some hair-raising mistakes. In this respect, a follow-up study came to the conclusion that the dark flow is by no means a physical phenomenon, as the primary anisotropy, or in other words, the directional dependence of the cosmic background radiation, was ignored in the previous study. In addition, the study of over 550 supernovae also revealed no impossible synchronous movement pattern, but instead a behavior that is easily consistent with our cosmological models. And then there is the data from ESA's Planck satellite, which once again provided no evidence of a mysterious dark stream. So can we finally shelve the theory of a hidden superstructure? Well, not quite, because Kashlinsky emphasized emphatically that the observations are based on data from over 1,000 galaxy clusters that were measured up to a distance of 3 billion light-years. A statistical coincidence can therefore be ruled out, and it's clear that the dark flow has not yet been definitively disproved. The question of what is behind it. And no matter what this may look like, if the originator of the dark flow really exists, this also means that there must inevitably be something behind our observable universe. And of course, Kashlinsky's researchers are neither the first nor the only ones to deal with the question of what this ominous behind might look like in detail. There is no need to emphasize at this point that dealing with this topic is always a matter of absolute speculation, and yet the corresponding theories are as different as they are astounding. And this is despite the fact that the first hypothesis sounds somewhat unspectacular at first. It actually states that the invisible universe is structured in exactly the same way as the observable one. However, things become much more breathtaking if we transport this scenario into an infinite space, because then we will ultimately find all kinds of things. And by that, we really mean all kinds of things. In this context, there is another solar system out there, complete with an Earth that is identical to ours in every respect, except that you may have had cornflakes instead of toast this morning. In another solar system, you may have skipped breakfast altogether, and in yet another, you got up this morning to rob a bank. Some experts even believe that there is an observable universe out there that is completely identical to ours. In other words, there is a version of you in the infinite vastness of space that mirrors your every action exactly. At first glance, this thought may seem beyond the limits of our imagination, but infinity also offers an infinite number of possibilities. Alternatively, we could just be in one of an infinite number of cosmic bubbles. In line with Kashlinsky's theory of an other universe, it is conceivable that the majority of the cosmos is expanding in an eternally inflationary manner, with this process only coming to a standstill in some bubble-shaped sub-areas. The individual sub-universes could contain their very own values of natural constants and subsequently also individual physical laws. The multiverse concept of string theory follows a similar line. True to the motto, every world that is conceivable also exists. We only exist because there must be a world among the countless universes in which the laws of physics are so perfectly coordinated that life can flourish. In detail, the ideas of string theory have now been further developed into membranes. Broken down, the quintessence of the whole thing is that these rippling membranes in the 11th dimension embody completely different universes, and as soon as the ripples collide, they form a new cosmos. One of the strangest aspects of this theory is the idea that all the gravity we experience in our universe is actually entering our world from another universe in another dimension. Ultimately, however, this theory could actually explain why gravity appears so weak here compared to the other fundamental forces of physics. And if you want our next video to appear on your homepage, you should pool your basic forces now and click on the subscribe button. Become part of our community and never miss an exciting video from us again. See you soon.